Hello viewers, in today's class we are going to solve some problems related to uh, definite integrals, right? So here what we will do, will solve some problems which are solved with the help of this property. So this is a very important property for the evaluation of definite integrals, right? Okay, so the property states that if we have a function f of x and we have to integrate it from 0 to a, then uh, the same function can be written as f of a minus x. It means uh, in place of the variable x, we can replace this variable x by a minus x, right? Okay, so now let us take this problem. Here we have to integrate e raised to cos x divided by e raised to cos x plus e raised to minus cos x dx. Now this problem, it seems very it looks very difficult at the first glance, but if we make use of this property, then this integral can be solved very easily. And let us see how we can integrate this function. So let us first call this integral as I, right? So this is integral 1, and now here f of x, is e raised to cos x divided by e raised to cos x plus e raised to minus cos x. Now in the next step, what we will do, we'll apply this property. So here the value of a is pi, and we'll replace this x in the next step by pi minus x, right? So x is replaced by pi minus x. So I becomes, using this property, 0 to pi e raised to cos for x, for this x, for this x, and for this x, will write pi minus x. So here we have cos pi minus x, and here we have minus cos pi minus x, and here we have dx, right? So using this property, this integral now takes the shape of this integral. Now I is equal to 0 to pi. Now we know that cos pi minus theta is equal to minus cos theta, right? So cos of pi minus theta is equal to minus cos theta. So this becomes e raised to minus cos x, and here we have e raised to minus cos x, because cos pi minus x is minus cos x. Here also we have minus cos x, plus e raised to, here cos pi minus x is minus cos x, so minus and minus becomes plus, so here we have plus cos x, right? Okay, now this is integral number 2. Now in the second step, in the first step, what we have done, we have applied this property, right? And in the second step, what we will do, we'll add these two integrals. So adding 1 and 2, right? Adding 1 and 2, what we'll get, here we have I, here also we have I, so I plus I, right? And here we have this integral, and here we have this integral. So this is 0 to pi e raised to cos x divided by e raised to cos x plus e raised to minus cos x dx, plus this integral. So here we have 0 to pi, then we have e raised to minus cos x, then we have e raised to minus cos x plus e raised to cos x and dx. Now I plus I, it becomes 2i, right? And here we have this integral is common, so we have 0 to pi, and we can write e raised to cos x plus divided by e raised to cos x plus e raised to minus cos x, plus then we'll write this function, that is e raised to minus cos x divided by e raised to minus cos x plus e raised to cos x, right? And this bracket closed, and here we have dx. Now we see that this denominator and this denominator both are same, so in the next step what we can write, 2i is equal to 0 to pi. Then we have since these two denominators are same, so we can write e raised to cos x plus e raised to minus cos x. Here we have dx, and we'll simply add the numerators. So the numerator we have e raised to cos x plus e raised to minus cos x, right? And now we see that here, so the numerator and denominator are equal, so we have 2i is equal to 0 to pi, and these two get cancelled, and we are left with 1 dx, right? And the integral of 1 dx is simply x, and we have 0 to pi, right? Now 2i is equal to pi minus 0, and 2i is equal to pi, and I is equal to pi by 2, and I is integral from 0 to pi e raised to cos x divided by e raised to cos x plus e raised to minus cos x. So the value of this integral is pi by 2, right? So viewers, this is how we see that with the help of this property we can easily solve the integrals of this type.